Okay, so picture this. You're in the cockpit, descending through a solid wall of clouds. You know the ground is getting closer, but you can't see a single thing. There's no horizon, no landmarks, just the hum of the engines and the glow of your instruments.
Your entire world has shrunk to this one task, flying down a perfectly invisible path to a runway that you just have to trust is down there. You know, this is the real challenge of instrument flight, and it's one of the most demanding skills in all of aviation.
So, how in the world do they pull it off? Well, the answer lies in this really remarkable piece of technology that has, for decades, been the absolute backbone of aviation safety.
It's called the Instrument Landing System, or ILS for short, and at its core, it's actually elegantly simple. You've got a set of transmitters on the ground that create this precise three-dimensional path right to the runway using two intersecting radio beams.
So let's break that down. The whole system works with two different radio beams. First, you've got the localizer. Think of that as your left-right guidance. It keeps you perfectly lined up with the runway center line. Then you have the glide slope. That's your vertical guidance, telling you if you're too high or too low. And the cool part is, your navigation radio pairs them up automatically. You just tune the localizer frequency and boom, you get the glide slope too. Together, they create that perfect, invisible highway in the sky.
But here's the thing. You don't just happen to find this beam. Flying an ILS is a super methodical process, and it actually starts long before you're anywhere near the airport. The absolute key is workload management, getting everything done early so you can focus when things get really intense.
You grab your approach chart, which has all the critical info. First thing, you tune in the localizer frequency. Then, and this is crucial, you confirm it's the right one. You dial in the final approach course on your instruments, and finally, you set your decision height. Now hang on to that last one. It's a big deal, and we'll come back to it.
So, about identifying the station, this step is absolutely vital. How do you know for sure you've tuned the right station and not some faulty or distant signal? You listen. It's actually kind of old school, but it's foolproof. Every ILS broadcasts its own unique little identifier in Morse code, so you hit the ident button, you listen for the dits and dahs, and you match it to the code on your chart. It's a simple way to know without a doubt that you're trusting the correct signal.
All right, once you're all set up, the next phase kicks in. You're probably still miles out from the airport, and now air traffic control has to guide you onto that invisible highway in the sky.
ATC is going to give you what we call radar vectors. These are just specific headings for you to fly. What they're doing is positioning you for a nice, smooth, shallow intercept of that localizer beam, usually at an angle somewhere between 30 and 45 degrees. This is all to make sure you don't just blow right through the course.
And you know, this is a moment of pure anticipation in the cockpit. As you're flying that heading from ATC, your navigation instruments, well, they're just showing an off flag. They can't pick up the signal yet. You're flying blind, just waiting. And then, as you get closer, the needles suddenly spring to life. And for the first time, you get a real picture of where you are in relation to that final approach course.
Okay, so you've captured the localizer, you've hit the next critical gate in the process. Now your focus shifts from just setting up the navigation to physically getting the airplane ready to touch down.
So it's time to slow things down. You'll start extending the flaps, and you'll drop the landing gear. Every one of those actions adds drag, which helps the aircraft descend at a nice, stable speed without picking up too much momentum.
This all leads to a core safety concept in aviation, the stabilized approach. The big goal here is to have the airplane completely ready for landing before you even start the final descent on the glide slope. Why? Because it frees up so much mental bandwidth, letting you focus entirely on flying that path.
Now we get to the heart of it all. You're configured, you're on the localizer, and it is time to fly the beam. For the next few minutes, this instrument right here becomes your entire world. It's called the Course Deviation Indicator, or CDI. That vertical needle, that's the localizer for your left-right guidance. And the horizontal needle, that's your glide slope for your up-down guidance. The objective sounds so simple, right? Just keep both needles perfectly centered, forming a perfect little cross. But trust me, doing it requires incredible precision and concentration, especially since the signals get more and more sensitive the closer you get to the runway. Pilots have a great name for it, chasing the needle. If that vertical needle drifts to the left, you've got to fly a little left to get it back to the center. If the horizontal needle starts to go up, that means you're too low, so you have to ease up on your descent to catch it again. It's this constant, delicate dance of tiny, smooth corrections.
And there's a very specific technique for starting that final descent. You always intercept the glide slope from below. This is a huge safety thing. It's to make sure you don't accidentally lock onto a false glide slope, which is basically a reflected signal that could guide you down a terrifyingly steep path. So you hold your altitude, wait for that horizontal needle to come down to the center, and only then do you begin your final descent to the runway.
Now, as you're descending, you're flying toward one single critical point in space, the decision height. Remember that altitude we set earlier? This is it. This is the absolute minimum for the approach. It's the moment of truth. For a standard Category 1 ILS, which is the most common kind, that decision happens just 200 feet above the ground. I mean, just think about that for a second. You're hurtling along at over 100 miles an hour, just 200 feet from a runway you still might not be able to see.
This is exactly where the decision is made. When the altimeter calls out minimums, you snap your eyes up from the instruments. If you can see the runway environment, the approach lights, the runway itself, you continue and you land. If all you see is gray fog, that's it. You push the power up and execute a missed approach, climbing away safely to try again. There is no in-between.
The ILS completely revolutionized aviation. It made air travel unbelievably safer and way more reliable in all kinds of weather. It really is a testament to both incredible engineering and incredible pilot skill.
But, today, we've got these advanced systems that allow for auto-land, where the airplane itself flies the ILS all the way to touchdown with zero pilot input, even in zero visibility. And that leaves us with a really fascinating question. In an age where automation is taking over, is that fundamental, hands-on skill of flying the needles still as vital as it once was? It's definitely something to think about.